7. A straight line joins the points A, -2, -3, and C, 1, 9. A. Find the equation of the line AC in the form y equals mx plus c. So for any straight line, we know that y equals mx plus c, where m is the gradient and c is the y-intercept. And we can find the gradient between any 2 points using the formula y1 minus y2 divided by x1 minus x2. So if we apply this to points A and point C, we get -12 over -3, which is equal to 4. So now we know that m is equal to 4. So the equation is y equals 4x plus c. Then all we need to do is substitute one of the coordinates into this equation. So if we take the point C, it means that when x equals 1, y equals 9. So if we substitute that in to find c, we get 9 equals 4 multiplied by 1 plus c. And we can solve for c to get c equals 5. So now that we have m and we have c, we have everything we need to write the equation of the straight line in the form y equals mx plus c. So that's y equals 4x plus 5. B. Calculate the acute angle between AC and the x-axis. Okay, so if we first sketch the straight line, y equals 4x plus 5, we know that it will cross the y-axis at 5 and it will have a gradient of around 4. So it should look something like this. And the acute angle between AC and the x-axis corresponds to this angle over here between the x-axis and the straight line. Given that the gradient is equal to 4 or m equals 4, the gradient is change in y over change in x. This means that if we draw a triangle or a right angle triangle anywhere underneath the line to find the gradient, it will have a ratio of 4 to 1 or something like this. So the change in y will always be 4 and the change in x will always be 1. So we can use trigonometry applied to right angle triangles to find the acute angle, where 4 would be the opposite side and 1 would be the adjacent side. So we can use tan theta equals opposite over adjacent. So this means that tan theta equals 4 over 1. Therefore, theta is equal to inverse tan of 4 over 1, which equals 75.9638. And for angles, we will always round to 1 decimal place. So that's 76.0 degrees. C. ABCD is a kite where AC is the longer diagonal of the kite, B is the point 3.5, 1. Find the equation of the line BD in the form y equals mx plus c. If we do that, remember that points A and C are -2, -3, and C is 1, 9. For these questions, it's always easier if you roughly sketch out what it should look like. So I'm going to roughly sketch out what it would look like. So point A is here, -2, -3. Point C is 1, 9. So it should be like this from each other. And that is the line AC, which is the line y equals 4x plus 5, which we worked out from the first part of the question. It says that point B is the point 3.52. So it should be to the right of A and C, somewhere around here. So it makes a kite. So if I joined A and B and C, the point D should be on the other side of the diagonal, and it should be also the same distance from the midpoint of the kite from B to D. So D should be around there. And the diagonals of a kite always make a right angle in the middle. So for the question, we want to find the equation of the line BD over here, this line, in the form y equals mx plus c. We already have one coordinate that passes through the line, which is the point B. So all we need right now is the gradient of that line. And line BD is perpendicular to line AC. For gradients that are perpendicular, the gradient will be the negative reciprocal of one another. And we already know the gradient of AC. AC is the line y equals 4x plus 5. So the gradient of something perpendicular to AC would have a gradient of minus 1 over 4. So we know that m for the line BD has to be minus 1 over 4. So BD must be y equals minus 1 over 4x plus c. And it also passes to the point B. This means that when x equals 3.5, y equals 2. And we can use this to substitute into that equation for the straight line to work out c. And we get c equals 23 over 8. So now that we have c and m, we can write the straight line in the form y equals mx plus c. So that's y equals minus 1 over 4 x plus c. Two, the diagonals AC and BD intersect at minus 0.53. Work out the coordinates of D. So the point in the middle of the kite over there is minus 0.53. And we want to work out the coordinates of D. The distance from B to that point and from that point to D must be the same, and the translation will always be the same as well because it's the same thing. It's the middle of the kite. So in terms of translation, from B to that midpoint where they intersect, from B to that point, we translate it by the difference between the x coordinates of the point, so that's minus 0.5 minus 3.5, and then the difference between the y coordinate, which is 3 minus 2. So the translation that represents going from B to the coordinates of the points of intersection is minus 4 and 1. So the translation from the midpoint or that coordinate to D must be the same as well. So to get from the point minus 0.5 to 3, we need to translate it by minus 4 and 1. So we need to minus 4 to the x coordinate, and we need to plus 1 to the y coordinate. And this gives the coordinates of D to be minus 4.5 and 4. So D is at minus 4.5 and 4.